Hi, I'm Abhiraj, and this is my engineering walkthrough for HAQMS assignment. When I first inherited this code base, the core functionality was there, but it suffered from severe production blockers, critical security vulnerabilities, and massive database bottlenecks, and thread unsafe race conditions. My approach wasn't just to make it work, but to harden it into a secure production ready system. Let's take a look at what I built. So let's first log in as a receptionist. I have created demo accounts. So here is the decoupled Next.js frontend securely communicating with our Express API layer. So as a receptionist, I have instant access to patented patient registers. Notice the seamless loading states. I overhauled the UI to properly wait for asynchronous authentication context to load, preventing those jarring split-second red bars. And if we jump over to the live queue monitor, this is the fully public route. I explicitly stripped the authentication middleware of the queue polling endpoint, so authenticated displays like a TV in hospital lobby can fetch live data without throwing 401 unauthorized errors. Now let's look under the hood. The first major hurdle was authentication security. The original backend was carelessly logging incoming plain text passwords to server console and leaking hashed password string right back into the client's API response payload. I sanitized the entire authentication controller to strip all sensitive payload data before even it leaves the server. More importantly, the JWT verification process had an ignore expiration flag turned on. I completely removed the that bypass, enforcing strict cryptographic expiration limits so hijacked tokens can't be reused indefinitely. Moving on to the database security. The admin search component originally had a massive SQL injection vulnerability, but it was taking raw user input and concatenating it directly into a Prisma very raw unsafe command. To neutralize this, I completely refactored the query controller. I migrated the endpoint to use Prisma's native .find many object relational mapping. By pushing the search criteria into a Prisma contains filter, the ORM automatically parameterizes the input. This treats user strings strictly as literal data, mathematically eliminating the injection vector. Next, I tackled a massive performance bottleneck, the n plus 1 query problem. When fetching the daily appointments list, the servers was initially looping through every single appointment, firing off a separate database ping to fetch the associated patient, and then another ping to fetch the doctor. So if you had 50 appointments, you were hammering the database with over 100 sequential queries. I solved it by leveraging Prisma's relational include feature. Now we retrieve all the base appointments and the associated foreign tables in a single highly optimized SQL join statement. The performance difference under the heavy load is night and day. Finally, I want to talk about data integrity and concurrency. The original application suffered from a severe read modify write race condition in the appointment booking engine. Two receptionists clicking book at the exact same millisecond could both read that a time slot was available and subsequently double book a single doctor. To fix this, I wrapped both the availability check and the creation mutation inside an interactive Prisma transaction by explicitly setting the transaction isolation level to serializable. I instructed the PostgreSQL database to log those rows. Concurrent booking attempts are now safely queued and evaluated atomically, completely eliminating the chance of a collision. Beyond all this, I cleaned up React hydration boundaries, decoupled all our hard-coded local variables into dynamic environments for Vercel, and built out robust paginated state management. Building hospital appointment and queue management system wasn't just an exercise in writing full stack code. It was an exercise in thinking like a senior engineer, protecting the data layer, prioritizing the user experience, and anticipating how a system behaves under concurrent stress. Thank you to the Figital Labs team for your time, and I look forward to discussing the architecture with you further. Thank you.